Every great architect needs to know the language of their materials, right? So our first layer here is all about building that foundational AI vocabulary. This just makes sure we're all on the same page, speaking the same language, as we start moving up the stack.
I want you to think of the AI landscape like one of those Russian nesting dolls. The biggest doll, the one on the outside, is artificial intelligence. That's the really broad goal of just trying to mimic human intelligence. Then you open it up, and inside you've got machine learning, which is the method of learning from data. Go one layer deeper, and you find deep learning, which uses these super complex neural networks. And right at the very core, you've got generative AI, which is the stuff that creates brand new content. Now here's a huge tip for your exam. All generative AI is a form of machine learning, but not all machine learning is generative AI. Remember that one.
So how does machine learning, actually learn? Well, it really boils down to three main techniques. First, you've got supervised learning. Think of this as the teacher. You give it a bunch of labeled data, this is an apple, this is an orange, and it learns to predict outcomes, like classifying spam emails. Then there's unsupervised learning, which is like the explorer. It just sifts through unlabeled data to find hidden patterns all on its own, like grouping your customers into different segments. And finally, you have deep learning, which we call the brain, using those really complex neural networks for tricky tasks like image recognition.
Okay, so those concepts we just talked about, they power the 5 key AI workloads that you're going to need to know. We've got generative AI for creating content, agents and automation for building systems that can work on their own, speech and text for understanding language, computer vision for, seeing and interpreting the visual world, and information extraction for pulling specific data out of documents. And what's really important to remember is that you don't just use one of these. You often combine them to solve really complex business problems. All right, our vocabulary is in place. So now let's put on our architect hats and actually deconstruct an AI application. We're shifting gears here, moving from the what to the how. We're going from these abstract ideas to the actual concrete structure of modern software.
And this is a really fundamental shift in thinking. You see, traditional software is basically a static box. It has hard-coded rules, and it gives you a fixed output. An AI application, on the other hand, is a dynamic, living system. It's powered by a model that can actually get smarter and improve over time through retraining. It's the difference between, say, a simple spell checker with a fixed dictionary and a language translation tool that gets better and better with every single sentence it sees.
Let's start building our AI app right from the ground up. The absolute foundation is the data layer. This has everything from your structured databases to your unstructured images. And you've got to remember the old saying, garbage in, garbage out. Without a solid, clean data layer, your AI model is just going to fail. Now, sitting right on top of that is the model layer. This is the brain of the whole operation. It's where you select, train, and deploy your AI models.
Okay, next up is the compute layer. This is the engine that actually gives the model life. It provides all the processing power it needs to run. Now, this can be anything from simple serverless functions, which is just code that runs on demand without you having to manage any servers, all the way up to massive Kubernetes clusters, which are kind of like these highly organized teams of computers all working together on huge, complex jobs. And finally, at the very top, you have the orchestration layer. This is the interface, the part that connects the model's intelligence to the user through things like APIs and agents.
So, we've designed our AI application architecture. We have the blueprint. But where do we actually go to build this thing? Well, that's where Microsoft Foundry comes in. I want you to think of it as this unified, high-tech factory where all 4 layers of our application get assembled. Microsoft Foundry really tackles the biggest headache in AI development, and that's complexity. It's a single, unified platform that brings together models, intelligent agents, and all your governance tools. Now, for a business, this is huge. It means dramatically increased speed to market. Instead of spending months setting up servers, a developer can use Foundry, grab a pre-trained model, and deploy something like a sentiment analysis app in just a few days. It really lets you focus on building cool, innovative AI apps instead of just managing servers.
So let's look at Foundry's 2 core capabilities. First up, you've got the model catalog. This thing is like a massive library of pre-trained brains. Seriously, you get access to thousands of models from Microsoft itself, like GPT-4, and also from partners like Meta and Mistral. You don't have to build them from scratch. And second, there's the agent service. This is where you build autonomous workflows. These agents can reason, they can make decisions, and they can call other tools to complete these really complex, multi-step tasks all by themselves.
And it's not just models and agents. Foundry also gives you a whole suite of tools that are kind of like pre-built sensors for your software.
You can easily plug in Azure Vision to let your app analyze images, or use Azure Speech for text-to-speech and translation, or even Azure Language to summarize text and pull out key phrases. These are incredibly powerful, ready-to-use capabilities you can just drop right into your applications using APIs, and that saves an enormous amount of development time.
Now, listen up, because this topic is an absolute must-know for your exam. Responsible AI. Look, building powerful AI is one thing, but making sure it's safe, fair, and transparent is absolutely critical. Just imagine releasing an AI tool that gives biased results. I mean, the damage to customer trust and your brand's reputation could be immense. Foundry's Governance and Observability Dashboard gives organizations a single place to monitor everything, from content filtering to policy compliance. This gives you the control you need to deploy AI confidently and avoid all those potential ethical and reputational nightmares. So, we've seen the concepts, we've seen the architecture, and we've toured the factory. Now for our final layer, let's zoom all the way out. What is all of this stuff actually built on? Well, the answer is the global, massively scalable cloud infrastructure of Microsoft Azure.
To really work with Azure, you have to understand how it's organized. It's a hierarchy. So at the very top, you have the tenant, which represents your entire organization. Then, inside that, you have subscriptions, which are usually used for billing or separating different departments. Inside your subscriptions, you create resource groups to hold related things together. And finally, inside a resource group are the actual resources themselves, like your Foundry project. This whole structure is how you manage permissions, track costs, and just keep your cloud environment neat, organized, and secure.
So how do all these different services talk to each other securely? The answer is something called API authentication, and trust me, it's way simpler than it sounds. Think of it like this. Every time your application wants to use an AI service, it sends a request. That request needs two things: an endpoint, which is just the public address of the service it's trying to reach, and an authentication key. The key is basically a secret password that proves your app has permission to access that service. It's that simple. The endpoint is the address, the key is the password.
Okay, one last important distinction when you're working in Foundry on Azure. You need to know the difference between a project and a hub. A project is your hands-on workspace for building agents and applications. A hub, on the other hand, is a central connector that lets you share resources, like maybe a pre-configured speech service, across a whole bunch of different projects. So for the exam, just remember this. Projects are for building, hubs are for sharing.
Woo! We have covered a lot of ground, from these super high-level concepts all the way down to the nitty-gritty of infrastructure. So now, let's bring it all together and lock it in for the exam with one final rapid-fire review. This is all designed for maximum recall. Let's do it. Okay, let's cement this with our cheat sheet. Top left, concepts. Remember that AI hierarchy. AI is the big goal, machine learning is the method, and Gen AI is for creation. Top right, architecture. Think of the 4 layers. Data is the foundation, the model is the brain, compute is the engine, and orchestration is the interface that connects it all. Bottom left, Foundry. That's your unified factory, giving you models, agents, and governance all in one place. And bottom right, infrastructure. That's the Azure hierarchy. Tenant, subscription, resource group, resource. And remember, security is handled with an endpoint, the address, and a key, the password. This one slide, this is your blueprint for the exam.
We've literally walked through the entire stack, from a single idea all the way to a global cloud. You now have the complete blueprint for understanding Azure AI. The theory, the architecture, the tools, the infrastructure, you can see how it's all connected. You are ready. So the only question left is, with all this new knowledge in your hand, what are you going to build first?